Hello class 8 students, welcome to the e-learning classes of physics. So today we are going to start our first chapter, that is matter. Okay, and our major point of interest are matter, that is what is matter, kinetic theory of matter, intermolecular space, intermolecular force, change of state of matter at constant temperature. Clear? Now, before we going to start the chapter, tell me why we need to study this chapter. What is the importance of this chapter? Think. Well, we need to study this chapter, matter, because you know what? Everything in this planet, in this universe, is made up of tiniest particle, isn't it? That is matter. Okay, and you already know that matter. What is the definition of matter? Matter is anything that occupies space and has some mass. Clear? Fine. Now, you also know that matter, the states of matter are three. Those are solid, liquid, and gas. But do you know the fact that it is not three, it is five? We'll discuss the 5 states of matter in chemistry. Clear? But in physics, we'll discuss only 3 states of matter that you already know, that is solid, liquid, and gas. Clear? Now, what is solid, what is liquid, what is gas? I'm not going to that part because you already have studied before in class 6 and 7. Okay? Let's move that. What is kinetic theory of matter? This is very important point in physics from this chapter. Okay? Let's note down this point. Please note it down. The first point is every matter is made up of very small particles called molecules. Clear? Number 2 point. Molecules of a given substance are alike in all respects. Means what? Suppose this is a green board, isn't it? The molecules which will be present over here and over here will be similar. Clear? The molecules, say this is chalk. The molecules over here in this chalk and over here will be similar because this is the same substance. Understood? Third point is molecules of different substance have different shapes, size, composition, properties. Suppose you are comparing with this blackboard with this chalk. Okay? You will find that the particles of this blackboard is different. Sorry, this green board. Okay, whatever it is, this particle of this green board and the particle of this chalk will be different. Clear? Might be the particle of the chalk is much smaller than the size of the green board. Clear? Next, note down the point number 4. Molecules of a given substance are constantly in motion. Remember all this. The molecules always move randomly. They are always in motion. Okay. Point number 5. Molecules of a given substance have space between them. We call it, that particular space, we call it intermolecular space. What is intermolecular space? The space between the molecules are called to be intermolecular space. I'm going to discuss more further regarding this. Okay. Note down the next point. Molecules of a given substance have space between them called intermolecular space. Next, molecules of a given substance attract each other with a force called intermolecular force of attraction. Clear? Remember, all the molecules attract each other with some force, and that particular force we call it intermolecular force of attraction. Focus in this diagram. Suppose these are the molecules of any liquid. Clear? Now, the molecule, what I told you, that intermolecular space, the space between the molecules, say this is a one molecule, this is one molecule. Clear? The space between them is termed as intermolecular space. Clear? The space between the molecules are called to be intermolecular space. These spaces are called to be intermolecular spaces. Understood? And what is intermolecular force? the force of attraction between these molecules and these molecules, they will attract each other. They will always attract each other. Clear? This force of attraction between the molecules are called to be intermolecular force of attraction. Clear? Well, next we move on to change of state of matter at constant temperature. Remember, at constant temperature, the temperature should not vary. Okay? Check this diagram. Follow this. Look, you already know there are three states of matter: solid, liquid, and gas. Okay? Well, when any states of matter undergoes changes, what happens? Either it will liberate heat, or else it will absorb heat. Always remember, any states of matter, okay, any states of matter, it changes from one state to another when only there is a energy change. Either you give it or you take out heat from it. Clear? So, suppose there is a solid. Let's assume that this is an ice. Let's take an example that this is an ice. Clear? When you give heat, say you are giving heat to it. You are giving heat to it. What will happen? Ice will absorb that heat, isn't it? And it will transform itself to liquid. Ice will change to water. And we call it melting. The process is called to be melting. So when melting will occur? If and only a solid substance, okay, it will absorb heat to transform itself to liquid. Means in simple way, if you give heat to solid, solid will transform to liquid. Clear? Similarly, what will happen when you give heat to liquid? When you give heat to liquid, means liquid will absorb. Clear? Once liquid will absorb, it will transform to gas. Now the question should arise to you that why, if you give heat, the solid will change to liquid? Why? The major cause is when you give heat to solid, the particles absorb the energy. Clear? And once it absorbs the energy, it starts vibrating. Vigorously it will stop vibrating. It will start vibrating. It will start vibrating. Clear? And once the solid will start vibrating, it will move far apart. Okay? It will move far. So now, as the solids, you know that solids are closely packed. Clear? Now, when these solids absorb energy, it starts vibrating. And once it starts vibrating, it will move apart. And it will change its form solid to liquid. Clear? Similarly, when liquid will absorb heat, it will start vibrating more. The kinetic energy of the particle will be more. Clear? What is the kinetic energy? What does the term kinetic energy means? Kinetic energy means, in simple way, you can understand, kinetic energy is the moving energy. Simple. When any particle is in the state of motion, it has kinetic energy. Clear? Now, when you give heat to the liquid absorbs the energy and transform it to kinetic energy. Means what? The kinetic energy of the particle is now maximum. Clear? And it starts vibrating vigorously and transform itself to gas. Clear? And we call it evaporation. Understood? Well, now this, what we have discussed is melting and evaporation, is the process when we give heat to it. Now let us understand the process when we take out heat from it. What will happen? What will happen? Suppose there is a gas. Okay, there is a gas. Now, how it looks? Gas molecules. Say gas molecules looks like. So this is the molecules of gas. Okay. Now, what will happen when you take out heat from it? You are taking out. So what will happen? This will come closure. The intermolecular space between the molecules will be now small. And what will happen? it will come closure. So once it come closure, say this has become now like this. Once it come closure, it will transform to back to liquid. Are you getting my point? It will transform to gas to liquid because it is getting closure. And we call this process as condensation. We call it condensation. Next, what will happen if we take out heat from liquid? Look, if when we are taking out heat from any of the states of matter, we are taking out means what? We are taking all the kinetic energy which we have given to them. Understood? So when they are having less kinetic energy now, they can't move vigorously. They will come closer to each other because intermolecular force of attraction becomes maximum and intermolecular space becomes minimum. And remember, if intermolecular space becomes minimum, means it is coming closer, intermolecular force of attraction will be maximum. I can give you one example. Let's take a magnet. Let's assume that this is two magnets, okay? Now tell me, when you're taking it closer, what happens? It attracts. But when you take it to the largest distance, what happens? It does not attract. Why? Because remember, when the molecules are closer to each other, they attract. But when the molecules are far, they cannot attract. Their intermolecular force of attraction is very less. That's why it moves far distance, and we call it, that states of matter, we call it gas. Okay, come back to this. When we take out heat from the liquid, take out energy basically from the liquid, it transforms back to solid because the molecules cannot move vigorously now. It have to contract more. Okay, and when it contracts more, it becomes tightly packed, and we know that when the molecules are tightly packed, it's called to be solid. Is that clear? And we call it freezing. So basically, your refrigerator, when you keep a water and turn your switch on of your refrigerator, what happens? Your refrigerator actually takes out the energy from your particular water or any milkshake or whatever the thing is. It takes out the water and makes it solid. Clear? How? By taking out the energy from it. Is that clear? So this was the basics of change of states of matter. One more point: sublimation and deposition. What is this? When solid directly changes to gas, we call it sublimation. Whereas when gas directly converts to solid, we call it deposition or desublimation. Remember, I can give you one example. Let's take an example of naphthalene. Hope everyone have in your home naphthalene balls, okay? Isn't it? Naphthalene balls. What happens when you keep naphthalene balls in any surface? What happens? That is solid, isn't it? You keep it and leave it for the time being. Let's take for a few hours. You just leave it over there. After that, when you come back, you see that either there is no naphthalene balls left, or else you will find it has become very little, very small. Why? Because the naphthalene balls, that is in the form of solid, has absorbed energy from the atmosphere. Okay, from the atmosphere, and it transforms it directly to gaseous form, not in the liquid form, liquid phase. It transforms directly to gaseous form. That is a fine example of sublimation. That is naphthalene balls. Clear? Now, what is the example of deposition? Let's take, this is in the gaseous form now. Let's take that this part is filled with gaseous naphthalene. What we do? Collect this gaseous naphthalene. Clear? Collect this gaseous naphthalene and don't give, and take it out. Take out heat from it. When you take out heat from it, energy from it, it will again form solid. That is, when any naphthalene gas that is in gaseous form, if you take out heat from energy from it, basically it will directly transform to solid. Is that clear? So let it be today till here. Next day we'll discuss some more topics from the first chapter. Okay, thank you.